may have even done an example that produced that exact equation. What is that graph going to look like if I graphed voltage as a function of time? So if my analysis spits out some equation, how do I interpret that? What does that look like if I graph voltage as a function of time?
Shift it up
any guesses, or
Would it be the same look? Like the, but
that look?
yeah, but that 5 minus something, it's gonna shift it over some way.
Well, this thing right here, just that by itself,
Yeah,
has that look.
yeah.
Okay? So I'm taking 5 minus that. Okay, well, what does 5 look like on a graph? Here's what 5 looks like. There's 5. Nice, steady 5. So what's it going to look like if I do the white curve minus the yellow curve?
It's going to go like this.
So I'm doing this 5 minus that yellow, and
This thing is going to go like that at the 5.
with the hand gesture, in case you missed it, let's see, which way did it? Well, one way or the other. You think he did something like that,
Yeah, same thing.
saying it's going to start off at 0 and slowly flatten off to 5. Let's see, because the white minus the yellow. Well, 5 minus 5, 0, right? 5 minus a little bit, or excuse me, 5 minus 4.5 would be 0.5.
I was actually saying it was going to start at the 5, but
Wait, so the negative out in front
I don't know if
flips
that's
over
right
the
either.
x-axis, basically. That's what it's doing.
That minus right here?
Yeah, it's flipping it over, right?
Basically, well, it's the 5 minus that.
Yeah.
So I'm taking this line here and subtracting off this. When I subtract off the yellow down here, do you agree the yellow, by the time I get over here, the yellow is basically 0? Not quite. So I'm basically subtracting nothing. So let me get a different color for the combination. So this minus nothing, of course, is basically 5. This minus that, right at the very beginning, is 0, because it's 5 minus 5. And then I'll get that shape in between. So I'm taking the 5 and subtracting off that.
oh,
So I think this is pink. So the pink would be the combination of those two. Okay, Vaughn?
yep.
Vaughn just suddenly did this. I do that sometimes too. It fell.
Kind of. This is like an algebra when you have to do like transformations and dilations and stuff. Like,
It's kind of like back in algebra when you're shifting up and down, side to side, and you're trying to see how do I put together a graph. If you can't do this in your head, if you don't connect this to that, then you're really putting up an artificial wall between this, which is telling you what's happening in the circuit. You've taken all this effort, done all this math to figure out what's happening in the circuit, what's the voltage as a function of time. So you go and you get this equation, and but that equation isn't telling you anything as the engineer. So you need to somehow get this result and know what that result is telling you. Some equations are harder to figure out what they mean. So I understand that sometimes you'll get a funny result that's got all kinds of gobbledygook in it, and you might not be able to really interpret it very well. Or you might have to go to a computer and have the computer graph it for you in order to interpret it. And sometimes that's okay, but we want to try to take the most common ones and be able to interpret those results. What kind of circuit would this make sense for? The voltage is going to follow this pattern right there. So the voltage starts off at 0, then gradually climbs up to 5 volts. What kind of circuit would fit that? Well, the exact same circuit as before would fit that criteria, except the previous time I was looking at the current, this time we're looking at the voltage. The voltage across the capacitor, I call it VC. If I just close the switch, the instant after I close the switch, the voltage across the capacitor should be 0. The voltage can't change instantly. And then what happens is that voltage slowly charges up over time. So the voltage increases, 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 until it eventually stabilizes at whatever the voltage across the battery would be. So in order to make this match match up this, I first would need to pick the voltage of the battery to be 5 volts. What combination could I use for R and C to make it fit this equation exactly? 2 and 3? Which way? Doesn't matter. Correct answer. Doesn't make a difference. 2 ohms, 3 farads will charge up just as rapidly as having 3 ohms, 2 farads. Isaac.
What would it change if you had a resistor parallel with the capacitor?
Here.
Yeah.
Let's say add a 3 ohm resistor. Okay, so Isaac wants to know how could I predict what will happen if I put the 3 ohm resistor there? So let's not do the math, I think is what Isaac's saying. Can we use our intuition to figure out what's the circuit going to do when I put the 3 ohm resistor there? I'd like to answer Isaac's question, and I'd like to answer it in 5 minutes or so. The reason I want to wait 5 minutes is I think when I do this next item, we'll be in a position for me to turn that question around back at you and say, what do you think it's going to be? Okay, so first I wanted to start by looking at some equations. I'll come back to some equations later today. Next, let's talk a little bit more and then come back to Isaac's question.